This is part 7, where I fit the new head gasket, replace the cylinder head, install the cam follower, camshafts, and reinstall the timing chain without a case. Here is an overview before I start. So as you can see, cylinders 1 and 4 are both at top dead centre. And there's a closer view. My first job was to make sure the cylinder head bolt holes were totally clean and clear of any fluid. If any fluid is left in these holes, then the hydraulic pressure when tightening the head bolts could split the engine block. So this job is easier if you have got an air compressor, and if you do, make sure you wear hearing protection and protective eyewear, because obviously shooting compressed air into a hole is going to fire debris back out. Now you must make sure that the holes are totally clean and clear. If there's any grit in there, it would affect the torque values as you torque those head bolts down. So really make sure those are clean. Here I even use a longer one just to make sure I've definitely got every bit of fluid out of those holes, because fluid did accumulate while the car was waiting outside. And like they say, if you tighten it up with fluid in there, you'll get a hydraulic pressure which could actually crack the engine block, which would obviously be disastrous. And then we do need to clean all the surfaces down with something like cellulose thinners. Next comes the cylinder head bolts. It's normally considered sensible to replace such highly stressed items, but Honda says that they can be reused if the diameter of the thread isn't below 10.6 millimeters, measured at 45 and 50 millimeters from the tip of the end of the bolt. So I've made myself a little template here just so that I can see where 45 and 50 millimeters is from the tip of the bolt. So using a vernier, I then measure that, and according to Honda, as long as it's not less than 10.6 millimeters, it should be okay. So in the end I use my fingers there just to basically get the area in question. And there we are. That's showing 10.8, slight variation there. So I did that then for the rest of the bolts, and they all gave about the same reading. So I will reuse these, because if Honda say that's well within tolerance, then I assume they know what they're talking about. Also, the added cost of head bolts, they're not the cheapest item out. So I'll see how this goes. Hopefully it will all turn out okay. The other thing you need to do is obviously clean the threads on the bolts to make sure there's no debris on those threads. That again could affect the torque values when we come to using the torque wrench. So give them a good old clean. That one was particularly dirty. Before placing the head gasket back on, we must ensure that all the mating surfaces are totally clean, using something such as cellulose thinners. So I used cellulose thinners, as I still had some from when I used to do a bit of spray painting. So just remember, always use this in a very well ventilated area, as it's not very good for you and obviously extremely flammable. So give that a good clean and do the same again on the cylinder head. Time to actually lay the new head gasket down onto the engine block. Locate it using the 2 metal dowels on the top front of the block. Be careful when handling this gasket, as it's very sharp around the edges. So now carefully lay the new head gasket onto the block, locating it over the 2 dowels at the front of the engine. like so, and then brace yourself because you need to try and lift the cylinder head over carefully. Try and use the front of the car to support you if you can, and locate it onto the two metal dowels at the front, and then drop the head down like so. So it seems to be on. I'm just going to check round the edge now with the torch and just make sure I can see the edge of the gasket and that everything looks okay. And it all looks to be okay. So we can go on to now sorting the actual bolts out and popping them in. Now to pop the cylinder head bolts back, ensure they go back into the same holes that they originally came out of. So using the numbered bolts that we pre-numbered as we took them out, so this is bolt number 1, we need to lightly oil under the head, slightly off camera there, so lightly oil under the head, then under the washer, and then a small drizzle along the thread, and pop that in to number 1. And then number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, and I'll show you again for number 10. So oil under the head, a little bit on the washer, and a little drizzle along the thread. Number 10. Ensure that you follow this sequence when tightening. So with the 10 cylinder head bolts now in place, I'm just going to wind them all down to literally just finger tight. I'm not going to tighten them at all. It's just to take the spare thread up on each of them. So that's number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, and lastly number 10. Stage 1 is to torque all the 10 head bolts to 39 Newton meters in the correct tightening sequence. This is the tightening sequence that must be adhered to. So having set my torque wrench to 39 Newton meters, I then start with the first in the sequence, which is bolt number 1, which is in the centre front of the cylinder head. I'll speed the rest up. So on to number 2, number 3, number 4, number 5, number 6, number 7, number 8, number 9, and lastly in the back corner is number 10. Stage 2 is to angle tighten by 90 degrees in the correct tightening sequence. So using the angle gauge, we put that onto the head of the bolts. Make sure we lock the actual protractor part of it, and make sure your needle is set to 0. You can push that individually, the needle. Set that to 0, and then we're just turning 90 degrees to there. So that's bolt number 1 done. And number 2, 90. Number 3. You can hear it creak there. On to number 4. You do need to make sure nothing gets in the way of the bar as you're turning as well. Make sure you've got enough clearance to do the full 90 degrees, because here I hit the bonnet stay, which wasn't too clever. You can hear the bonnet there as I'm pushing the metal rod. So number 6. Then on to number 7. I think I hit the power steering here, so I had to very carefully lift the bar off and reset it, which I'd rather not have done. It wasn't going to go through the power steering pipe, so very carefully I lifted that off, reset my bar, and just finished the last few degrees to 90. So number 8. But obviously if you use a shorter bar, it's going to be harder to actually make that turn. So you want a long bar, but make sure it's clear. So bolt number 9. And finally, bolt number 10. Now we do need to repeat this procedure all over again. Stage 3 is to angle tighten each bolt by a second 90 degree turn in the correct tightening sequence. So this is the second time I'll be doing the 90 degree turn. And since I'm reusing the head bolts, this would be the final turn. So bolt number 1, 90 degrees. Bolt number 2. Bolt number 3. It's getting quite hard to now turn this. On to number 4. .90 degrees. Number 5. You can see there's quite a bit of strain going into that. I don't think I could do it with a shorter bar. Number 6. On to number 7. Number 8. Number 9. And finally, bolt number 10. So like I say, this is the last time I'll be doing this sequence. If you had new bolts, you'd have to repeat this again. Stage 4 is only if you're using new bolts. Is to angle tighten each bolt by a third 90-degree turn in the correct tightening sequence. Do not do this stage if reusing the old head bolts. Since I reused the old head bolts, there is no stage 4 to show in this video. I'm now going to replace the spark plugs to avoid anything falling into the cylinders. After putting those head bolts in, I thought it was too much of a risk to leave these spark plug holes open. So I thought best get them back in just loosely so that nothing could fall down there while I'm putting that cam assembly on, which is the next job. And spark plug number 4. So I'm just going to give this a clean on the top with some cellulose thinners, because we will be putting a bead of sealant down on the right hand side of the engine just before the cam follower assembly goes on. Now for the cam follower assembly with the camshafts still in place. It's important that you follow the correct tightening sequence for this part. So I'm just going to run a small bead of RTV sealant down on the right hand side, which is where the cam follower will sit. Now I have cable tied all the followers up so that I can just drop this down as one unit, like so. And then what I'll do, I'll just tap it down gently to make sure it's sat down on the metal dowels. So I'm going to pop the 2 bolts in on the right hand side. These are the smaller 6mm ones. And just wind all the other ones down loosely. And I can then cut the cable ties just holding the followers up. I cable tied them to the camshafts, otherwise they would have dropped underneath while I was trying to put the assembly down. So I'll just cut these ones on the intake camshaft. It should now also be safe to cut the 4 cable ties that we put on the inlets followers. So it's 22 Newton meters to start with, and we start in this sequence. That's 1, 2, 3, 4, 5. So it's important you do it in this sequence. 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19 and 20. So now we've still got the 2 6mm at the end and one of the 6mm in the middle that need to be done at 12 Newton meters. So the middle one would then be 21, and then 22, and finally 23. Refitting the timing chain. Check that cylinder number 1 is at top dead centre on the compression stroke by making sure that the arrow on the crankshaft drive sprocket and the crankshaft keyway align with the arrow on the cylinder block. Here's the alignment marks and my added white paint marks. I'll use a pencil to show the markings. So we also have some markings here on the sprocket, which we'll come to later. But note the marking here on the sprocket, the one on the cylinder block, and the keyway there on the crankshaft. I'll zoom in so you can see it clearly again. So there's the one at the top on the engine, there's the marks on the sprocket, and there's the keyway. Using two 23mm spanners, we can rotate the camshafts so that the two punched indentations on each cam is at the top, along with the arrow on the VTEC actuator. Also, the lines punched into the rims of the cams must exactly face each other at the 3 and 9 o'clock positions. If the valves contact the pistons, you may need to turn the crankshaft back 45 degrees to allow the cams to turn, but turn it back after. Here's all the alignment marks on the camshafts. So using two 23mm spanners, or if you have only got one, then perhaps use an adjustable spanner. The idea is we put these onto the camshafts, and then we need to get the alignment marks uppermost. But what will happen is the tension of the valve springs will push the cams apart. So we need to use a couple of cable ties that will hold those spanners tight in the correct position. So the springs are trying to push the cams and the cable ties are at the top holding them together. So under spring pressure they should stay there now, and you can adjust the alignment as necessary to make sure it's exactly right. Here's a view of the other end of the camshafts, which show the arrows I marked in white paint. So if we take another look at these two lines on the camshaft, as you can see those two must be facing each other exactly. So they're slightly off at the moment. And here's another shot showing the upper marks on the camshafts. There you've got the punch mark, the arrow, and the other punch mark on the exhaust camshaft. The timing chain has 3 blue coloured side plates. 2 are close together, being 7 links apart. These 2 plates must fit over the indentations on the intake and exhaust camshaft sprockets. The third blue side plate fits over the punch mark indentation on the crankshaft sprocket tooth. So here's a few photos to show you the indentations and the blue plates. So as you can see, the indentations are on the camshaft sprockets and the blue plates are on the chain. And this is the crankshaft. So I'm now taking the timing chain, making sure that I can see the 3 blue side plates and the 2 blue plates at the top, which are 7 links apart, I now put onto the camshafts, making sure that the blue plates are above those little punch marks. I can then adjust things with my 2 spanners and adjust the cable ties as necessary. So here you can now see the 2 blue plates above the indentations. I've also added my own white paint marks just for my own added security that I was putting it back exactly right. And here you can see the blue link that fits over the little punched tooth there on the crankshaft. Next is to refit the front fixed guide with its 3 bolts, requiring a 10mm socket, and these are torqued to 12 Newton meters. So this is now the fixed guard that goes to the front of the timing chain. This is held on with 3 bolts. 1, 2 and 3. So we need to just carefully drop that down there and pop those bolts in. Not the easiest. Space is tight. These will then be done up to 12 Newton meters. You may need to go under the car for the lower bolt. Now comes the tensioner guide blade, which pivots on a single bolt, requiring a 6mm Allen key and torqued to 22 Newton meters. So here's some shaky video showing how the timing chain looks at the moment. You can see the fixed guide is now in place, and we now need to put in the pivoting tensioner blade. So here's our tensioner blade with the single bolt, and that's a 6mm Allen key for that. Can be a bit tricky because the chain is actually leaning in that direction, so you've sort of got to push the chain forward a bit and locate that single bolt. If you're careful, again it is very awkward down there, space is somewhat limited. I'm now going to check my marks again, make sure that that blue link is still perfectly on the indentation on the exhaust sprocket. Now I do this up to 22 Newton meters. Again, it's quite tight even for this small torque wrench. It was a struggle to get that in there. There's our click. So that's that part done. Now the tensioner itself. 2 bolts requiring a 10mm socket, and these are torqued to 12 Newton meters. So this is a bit trickier for me as I've got a camera right where I need to be, but I've got to push the tensioning blade over, and at the same time I'm going to get 1 bolt in on the tensioner itself. So I've obviously got to check that link at the bottom is definitely in the right place on the crankshaft. So that's 1 bolt in. So we must watch that sprocket and the blue plate at the bottom and make sure it goes over the correct part on the crank, because you definitely don't want it a tooth out. So at the same time I'm going to swing the tensioner up, which is quite difficult here because I'm almost one-handed. But I'm going to swing the tensioner up, making sure that tooth is in the right place, and then put that second bolt in. So you've also got to make sure the plunger is on the blade in the correct position as well. So I'll just do that up by hand. And then we need to torque that to 12 Newton meters, those 2 bolts. So you might find for the second bolt you need a shorter socket. That one was too long, wouldn't fit. So using a shorter one now, we can just torque the second bolt. And then we can remove the pin from up above in the engine bay. Carefully pull that out, and then the tension's on the chain. Now the fixed guide to the top of the timing chain. 2 bolts may need removing to pop this plate back on, requiring a 12mm long reach socket, and these are torqued back to 22 Newton meters. So you'll probably have to remove the 2 bolts that we'd put in earlier on the cam follower assembly. So pop those 2 bolts back out, and then we can take our plate like so and pop it back over the top of the chain, drop the bolts back in, and then we can torque these back to 22 Newton meters. Like so. And then we can cut the cable ties on the 2 spanners and relax the tension onto the 2 camshafts. Refit the crankshaft position sensor now. Ensure it's not put on back to front and that the outside writing is clearly visible. So make sure your blue plate link is definitely in the right position, and then we can pop this sensor part back on, making sure the writing is on the outside. We now need to pop the crankshaft pulley back on temporarily so that we can rotate the crankshaft 2 full revolutions, which is 720 degrees. Now check all the timing chain marks are still correctly aligned and readjust if something isn't right. So using a 19mm socket and a couple of long extensions, rotate the engine through 2 full revolutions, like so. And then we need to check that the marks are all aligned. Lastly, in this video, we need to remove all the old sealant from the timing chain cover and engine block. Clean with cellulose thinners and reapply fresh liquid gasket. You should replace the black O-ring in the cover with a new one. So you need to remove all traces of the old gasket as carefully as possible, because you don't want to cause any deep grooves or damage. So carefully get rid of all that. And don't forget, you also need to do the bottom parts of the case, because that sits on the sump. And obviously you need to also clean all this area on the actual engine itself where it's going to sit. So the bottom is quite an important part, because that's where the oil sump is. Note the different bolt types prior to applying the sealant, as you may need to start bolting things back fairly quickly once the liquid gasket has been applied. All the bolts use a 10mm socket and are torqued to 12 Newton meters. So here's a photo showing all the bolt types. So I used THREEBOND 1184 liquid gasket, and you apply this as a bead to where I've put the red bead lines, so along the bottom there. So apply it everywhere where you see the red. And then lastly, we need to torque all those bolts to 12 Newton meters. Here are some detailed photographs with labels to help with identifying all the visible parts. I will put them on for only 4 seconds each, with the idea that you can pause them for detailed viewing. Thank you for watching, and please see part 8 in this series.